Meredith, you're ready to go.
Yes. Okay. Okay. Hello. So my name is Meredith Best. I'm with St. Philip's College, and I am the chairperson for International Education Week, and also a certified advisor at St. Philip's College. So welcome to the subjects of climate change, and I'll be introducing our guest speaker, Dr. Carmen Nava-Fischer. And let me share my screen quickly. So Dr. Carmen Nava-Fischer, Professor Fischer, was born in Leon, Mexico, and received her degrees at the Universidad Autónoma de Baja California in Ensenada, Mexico. While there, she finished her degrees in oceanography. She got her master's in marine biotechnology and a doctorate in biochemistry, environmental chemistry. She was hired full-time as an assistant professor at St. Philip's College in the Natural Sciences Department in 2008. And through her efforts, she was promoted and tenured. She has taught every course available through the Alamo Colleges in chemistry and earth sciences. She also served as the department chair and as the associate director of the Center for Excellence in Sciences, and also its Summer Academy. Currently, she is doing research on bioactive compounds for regional organisms, marine and terrestrial. She has built a strong reputation as a student-oriented teacher and collaborator. So this is Dr. Carmen Nava-Fischer. So I'd like to first let you know that if you have any questions, please put them in the Q&A. And once the webinar is finished, then we will go through those questions and answers, and Dr. Carmen Nava-Fischer will answer those. We will get started. All right, go ahead and get started, Dr. Fischer.
Okay, good afternoon, everybody. I hope you are doing good at home. Thank you, Meredith, for introducing me. And the first thing that I want to say is thank you, everybody that is here listening to this talk. First of all, I'm not an expert in climate change. However, I wanted to share with you what I have learned during the years. And I hope this enrich a little bit your knowledge, or maybe you will know more about climate change than I. So I'm gonna start by sharing my screen and showing you a little presentation that I have here for you, okay? So I'm gonna keep it in this way because that way I can really go forward and backward in regards to some videos that I also want to show you. So this is for the climate change international impact, and very much it goes very well with our International Education Week. So first of all, normally the people ask, do you believe in climate change? And then we start thinking, do I believe, I don't believe? And then you think very much in kind of the political way, you know, and it's kind of confusing. So I want to share with you something, first of all. I want to share this video. I'm going to be doing that backward and forward with sharing videos with you that I think they will be important.
Who can help? Gather round, brothers and sisters, join me. Are you ready to receive the healing? Ready to receive the light?
So, I can say that actually, do you believe or you don't believe in climate change? is not really what we should be asking when we talk about climate change, because we believe in God. We believe that tomorrow the sun is coming, so we have faith on that. But actually, climate change is not about believing. Climate change is about being informed. Are you informed about climate change? Do you know what's going on? Are you preparing yourself for future generations and what is going to happen if climate change happens? Okay, so first of all, let's define what is climate. Climate is the prevailing weather conditions of a region, of a huge region, average over 30 years. So what scientists do, they take temperature, precipitation, wind, air pressure, humidity, sunshine, cloudiness, and average the 30 years on this big region, and that's what we call climate, okay? And if we have that for years. The climate system actually involves the exchange of energy and moisture, which we can say involves the exchange of energy and matter in the different spheres. You see, we have the atmosphere, we have the hydrosphere, which is the layer of water around the earth. We have the geosphere, which is actually the land, including the ocean floor is the geosphere. We have the biosphere, which is all living creatures that are around the earth. We have the cryosphere, which is where we have the ice and the snow, which is the peaks and the mountains and the poles, the northern pole. So very much those spheres are the ones that are going to be exchanging energy and matter. And that's what makes the climate system. Vladimir Köppen classified the climate in a very kind of simple way. He just put very much going from the equator, starting with a tropical climate, then it went to dry, temperate, continental, and polar. And we also have the mountain, and there is variations, etc., of this climate. But we have been living with them for years, you know, so nothing was wrong. How do we measure these? Well, the measurements come from weather stations. They come also, and they have been actually collecting data since 1880. So you can see that we have really a good data of information about climate. We also have now 27 or probably a little bit more weather climate satellites in orbit, and they measure all kinds of features that can actually tell us about what's going on with our climate. They measure temperature, composition of the atmosphere, pressure, precipitation, sea surface height or low, because that will tell us that there is an exchange of matter, you see, and et cetera, So we have a constant measurement of our weather, and therefore from there we average and we take our climate. So what exactly is climate change? Well, climate change describes a change in the average weather conditions, such as temperature and rainfall in a region over a long period of time. Again, it has to be an average in a long period of time. So what happened is that lately, you know, and it's very much late 20 years, the scientists have observed that the Earth has become warmer and warmer, the Earth's surface. So what's going on? Well, very much what we have is the sun that comes or that we see every day with his very incredible radiation coming. And if we very much observe in very rough way what's going on with that solar radiation, we see that 50% of this radiation is diffused and is absorbed by the land and the sea. That's what we have. The land and the water absorbs the 50% of that radiation. Excuse me. The other 50%, it comes, 5% gets reflected. 20% is absorbed in the atmosphere and in the clouds. 5% gets actually a kind of from the atmosphere also scattered away. And another 20% is reflect from the clouds. So in the end, we very much lost 30% of this radiation that is coming, and 70% stay right here. So we have something, and probably you have heard about this, the greenhouse effect, which is actually a normal natural phenomenon and is a result of the Earth's atmosphere trapping some outgoing radiation. So you see, we have diatomic atoms, which diatomic compounds that very much are formed with two atoms. For example, nitrogen, we always say that is N2 because it's two atoms of nitrogen getting together to make that molecule, okay? And those kind of, and very much the 80% of our atmosphere is actually nitrogen. The other 20% is O2 and other compounds. So the other compounds, actually, they are not, several of them are not diatomic, but polyatomic, which means several. For example, CO2 is 1 carbon and 2 oxygens. Water, H2O, so it's 2 hydrogens and 1 oxygen. So those polyatomic compounds, what they do is that they let pass all the radiation from the sun. That's not a problem. But when this radiation, 30% is coming up, these kind of gases doesn't let go. They reflect back and they create the greenhouse effect. And therefore, that radiation that come in then goes up and comes down and goes up and comes down. So that's somehow the problem of how we are making our Earth being more and more warmer and warmer. So how do we do learning about climate change? Well, other of all those stations that we have about measuring all our weather, what is going on in this moment, our climate, we also actually have the scientists, which we call the paleoclimatologists. Those scientists go to places in the air where they take cores, they drill cores, which are like long tubes where they can observe what's going on before. You see, sediments in the bottom of the ocean, they are going to be reflecting what was going on in the moment that they sediment. The same happened with the cores in the ice, because when you take a core out, you will see different colors, and that will tell you the different concentrations that you have about different gases. For example, in the time when some ice was congealed, in that time, the concentration of oxygen is going to be right there congealed too. So more ice is congealing in the top, therefore this frozen water is going to be showing the amount of oxygen, the amount of CO2, or the amount of all the gases that were there. So that's why it's very important, these paleoclimatologists, how they measure these cores, and they measure how much oxygen, how much CO2 was there before. So with their help, we have found that for the 800,000 years, atmospheric CO2 was never higher than the level of 300 parts per million. Okay, remember, we do percentage when something we can divide it in 100 parts, but when we divide it in 1,000 parts, now we're talking about parts per 1,000. And when we divide it in million parts, now we're talking about parts per million. So we have 300 of those million little sections that has been the atmospheric CO2 with its ups and downs. And we see here how it's very much less cyclic going up and down. However, I want you to observe what is happening now. We are 100 parts per million higher than what we have been measuring before in nature. See? So that's what is worrying the scientists. So yes, there is a natural way of looking how CO2 is going, but also if we measure methane, we also see the pattern goes very similar. And if we have the temperature, calculating the temperature, we can find that is very similar. However, now look at all how we are going up and up in these gases, and the temperature has increased, has an anomaly of 1 centigrade more. So how these natural processes happening? Well, first of all, the natural processes happening because of this global or climate change, because first of all, our Earth doesn't go around the sun in the same distance, at the same distance. We have something that is called the eccentricity. The eccentricity happens every 100,000 years. Our Earth goes far, and then in 100,000 years, it goes closer. So it's getting closer, 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 closer until it gets here. And then it starts going far, 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 far. So yes, we have glaciations. We have times where the Earth is really cold because we are farther from the sun than usual. Well, we are getting closer. So that's telling us climate change is coming naturally. Then we also have the obliquity, the tilt. So the tilt is between 22.1 and 24.5 degrees. So we go every 41,000 years, the tilt goes up and then goes back. It takes 41,000 years. And then we have the precession, which is the movement of the Earth that goes in this direction. And the precession takes 23,000 years. Also the Earth, so you can see there that the changes actually matches very much what we have been looking like up and down, and up and down. And also we have, of course, internal forces. We have volcanoes, flood lavas. So these are forces that happen without anthropogenic, which means without the influence of human beings. However, we actually, in these kind of conditions, that was what we were observing before, not in the last years. So, what is happening with the climate, with the human impact in climate? Well, we have been raising the CO2 levels. And as I explained before, these waves come from radiation from the sun, and that's the normal, natural thing that is happening. But unfortunately, they get trapped. So they get trapped in this CO2. The increase in CO2 has made this increase in temperature from 1 centigrade. There are organisms, for example, corals, with 1 degree, 1 centigrade up, they die. 1 centigrade in the water, of the temperature of water, and they will die. So we also have fires because we have altering the ground cover, because we have now places where we don't have the amount of green that we used to have. So this is the global temperature anomaly. Look at how in 1880, which we start taking the data, this red line is actually the average of every 5 years. Look at how in 1940, we have this big bump. Then we went a little bit down, and then since 1980, very much, we start going up, up, up in temperature until now we are in 1 centigrade up. We take as a line base what we have here, okay? So how we will feel this impact of climate change? Well, according to the National Oceanic and Atmospheric Administration, NOAA, we are going to be observing a sea level rise and flooding, extreme heat and drought, extreme precipitation events. New records will exceed all records and typical conditions would start to resemble what we today consider extreme. So now the extreme is going to be the new normal, you see? And very interesting, all this difference in temperature, because you say, how can it be that in some places it's going to be raining a lot and in others it's going to be drought? Well, those two things together, what it makes is the whole environment to change. Because remember, we are in an earth system and it's connecting, and it's this energy transformation from one place to another, this energy exchange as well as matter exchange. Okay, so every summer some Antarctic ice melts, and then in the winter it recovers. However, since 1979, we have observed that the ice are thinner and thinner. So let me share with you the next, my next slide, okay? My next video, actually. So, coming back to this is not the only glacier that the scientists are studying. You see, there are several that in this moment are coming, entire mountains of ice are coming down to the ocean and raising the sea level. That's one of the ways that we are going to observe climate change. The other is flooding. See, and I have also something to share with you about flooding.
At the start of this century, another powerful flood wreaked havoc, this one coming from the sea. The storm surges of Hurricane Katrina submerged 80% of the city of New Orleans. Over 1,800 people died in the floods. The damage has been estimated at over $80 billion. In some ways, the New Orleans disaster was unique. Much of the city lies below sea level, and despite years of warning, the city was woefully unprepared to handle a breach of the levees which kept it dry. But we are still vulnerable. Sea levels may rise, coastlines could erode, rain patterns might change, snowpacks could melt, and then the waters would rush in.
That was about flooding, which is the other way we are going to start looking our climate change. And actually, you know, in the New York Times in November 10, a year ago, climate change is way worse than scientists have been saying. So far, the cost of underestimation have been enormous. And this was when New York City subway system that didn't float in the first 108 years, then it floated and it was devastated, causing a lot of money for the citizens. So NOAA, the same National Oceanic and Atmospheric Administration, created the weather.com Climate Disruption Index. They actually considering factors like cities that were with a population of 200,000 people, sea level rise, extreme precipitation and drought, urban heat islands, which that probably we have that here in San Antonio, because if you go downtown, you can feel the heat compared to you go around the areas of San Antonio. It's very much different in some degrees, and it is because when you are in an urban place, the asphalt and the buildings and the construction doesn't allow to have a normal, usual, natural temperature, but the temperature normally is hotter. That's why we call urban heat islands. So changes to average temperature and precipitation. So the NOAA use all those factors for creating an index. And of course, not all the scientists agree with this index. Very much what they found is this: they have like 25 top cities about how climate change has impacted them. And the ones that was the most impacted, the 7 main impacted cities were the ones that I am presenting in this table. And as you can see, the vulnerability is about sea level rise, for example, New Orleans, precipitation, urban heat island effect, hurricanes, very much extreme drought, and very much that is what we have, that is in this moment being observed with climate change. So here is some cost in human terms, you know, in the different places where some event has happened. So what's going on in this moment? Well, we very much are using still fossil fuels that currently provide 85% of the world's energy consumption. As you can see here in this graphic, since 1965, how we actually went down in coal utilization and we start using oil. So the nuclear, the renewables, and the hydro are still very low, even though we can use them. I mean, there they are. So this use of these fossil fuels produces 95% of the world's CO2 emission. So look at this. Then that rises the temperature of 1.8 Fahrenheit, which is approximately 1 centigrade, what we were talking about before, how we have been raising the temperature of our world, of our Earth, in 1 centigrade. So if we separate the human and the natural influence on climate, we can observe the following. We're supposed to be doing this up and down and up and down. But look at where are we? We are together, natural and human factors are going in this direction. So hurricanes and cyclones are becoming more intense. Wildfires are becoming more intense and frequent with longer seasons. See, in this moment, California was suffering about that. And for instance, actually, before I pass, just at the beginning of November, Philippines got a hurricane, a typhoon, that now we call them super typhoons. So now there is not the typhoon that we used to know. The winds were about 300 kilometers per hour, which that's 195 very much miles per hour. Can you imagine the winds that in that kind of strength? So what will happen if we actually continue utilizing all this fuel in producing all these greenhouse effect gases? Well, we are going to see, for example, a sea level changes, which will be, will go from zero point 0.2 meters to the stream of 2 meters. Remember that a meter is a little bit more than a yard, okay? But it's very much for our, for us, we can talk about meters like a yard, though it's 90 centimeters, but anyway, it's almost like that. So what's going to happen with the population? Well, look at this. The population keeps growing, you see? So in most, we are very conservative, Latin America, North America, we are very conservative in Oceania, but Africa and Asia still in a big process of growing by the year 2100. That's what is predicted. So global temperature is going to be higher. As we see here in South Texas, we have 30 days of more than 100 centigrade. In South Texas, we may have 5 days of 110, between 50 and 100 days of 100 Fahrenheit. If we go to the average sea level, as we were talking, as sea level rises is not uniform into some places. This map doesn't show very well, but in some places it's going to be higher than in other places like New Orleans are in a big risk. We already are observing that. And there are places here in Texas that are in a big risk that are already planning on moving or doing something because the water is coming every time higher and higher when they have a hurricane or when they have any other event. So precipitation also is going to be very uneven, because of the different changes on temperature. The land is going to be hotter, and because the water is still cold, the difference in this temperature is making the wind to go faster and faster. So possible consequence of climate change: altered distribution of the world's water resources and the effect on the productivity of agricultural regions. Rising global mean sea level, the changing Arctic, loss of sea ice, melting permafrost, the potential for climate surprises that we do not yet understand. For instance, I was reading the other day in an article that there are ices that has been stored for 30,000 years, which have bacteria and fungi that we don't even know. We don't even know about sickness that we are going to be having. This pandemic is one of the initial, probably, problems of health that we have all around the world. So we need to be prepared. And so my question is, what do we do about climate change? I think the best thing is not to say, do you believe or don't believe in climate change? Because as I say in the beginning, it's not a religion, it's not something of faith. It is about get informed. And then once you get informed, be prepared. Take wise decisions for you and your descendants. Remember that we don't inherit the earth from our ancestors. We borrow it from our children. So I want to share one more video. Let me just select it first. Okay. And this video is about just our world, to see how the distribution of gases happen and how we are all connected somehow. Okay, this is from 2006. NASA presented because of the year celebrating the Earth's year. So this is very much the carbon dioxide, how it goes. Look at how the North Hemisphere is actually sharing all this carbon dioxide. Very much in the South, we don't have that. So the end of this talk is actually asking you to be aware of what is going on in our world. We have a beautiful world that we are sharing. And as you can see, one thing you make in one place, one thing that happens in one continent goes and happens and influences the other. This exchange between energy and matter, between all the spheres that are covering our Earth, including the biosphere that is us, has to be aware, we as human beings, of sharing this world in a better way. So I want to finish my presentation with this. I want to thank you for being here, and I am looking forward for answering your questions, for listening to your comments, and to talk to you. Thank you very much.
All right. Thank you, Dr. Nava-Fischer. That was very informative. We do have a question in the chat, and I will go over that. It says, whose fault is it really for climate change to increase dramatically? Is it people, or is it the fault of, I guess he was saying people, if you can
yes, you know,
give
well,
your opinion on that.
yes, you know, when I was sharing my presentation, as you can see right here, and I don't know, you made your question before I was passing this slide. You see, we have the natural factors, as I say, because the Earth moves closer to the sun, because the Earth is tilted closer to the sun, etc., etc. But we actually, in this moment, have influenced our climate, our weather, our weather, everyday weather. You saw how in the last video that I passed, there was a lot of sharing. So you can see how some event that happens in Africa is going to influence the rest of the world. So it's like everything is mixing all the time. That energy and matter is exchanging. Therefore, who is responsible? Nature has his part, but if we add nature plus us, look at the difference between what naturally is supposed to be occurring. I hope this answered your question.
Yes. And I actually had a question. You talked about external orbital forcing from the Earth. So what cycle are we currently in?
We're getting closer. We are going to be in the closest time. The last global time was about 40,000 years ago. So we are about 3,000 years closer to the closest point. So, and then of course it has to be also with the precession, the tilt of the earth, where are we? And it seems like we are getting also on that path. So that's when a global warming, a complete climate change is going to happen. However, we are increasing it, and because of our human factors that we are using. And one thing that I forgot to say in the presentation is that we need to be prepared. You see, I say it in just one word. I say just, we need to be prepared. But actually, I will say that our form of government probably is not working as good as it was before. Probably we need to change. Our leaders are not as good, or are not, this form of government is not getting that good. We need to see about things that are very important for our future generations and ourselves, which is preparing for a climate change. Before, you know what? It was, oh, I'm sorry. I heard some telephone. Just give me 1 second. I told you, it's always somebody calling me. I'm sorry. My apology for that. You know, before I lost the track, I'm sorry. But anyway, we need to be prepared. That's very much what will be the end of my, what I will say, you know, be prepared. Instead of utilizing money for us fighting to each other, we as human beings, we need to be together and prepared. One thing that I want to add, and I'm sorry for being that long in your answering you, is this. We learn about Noah's Ark in the Bible. And I don't mean to make this a religious talk, but we learn that there was a flooding. How many times has this flooding happened? And we probably, the human beings, are in the top of technology and we are so good, then suddenly for not taking care of the natural phenomena, then we go down and we disappear. And then again, we start, you know, building and coming up, and then again, we disappear. How many times this has happened, nobody knows. So this is our time to be conscious and say, we need to prepare for big flooding, for big drought, for all these big changes that are coming. That's what internationally, and that's why I was very happy to present here, because that's what internationally we should do. We should get together to prepare, not to fight between each other, you know, but prepare for these natural and probably human-made events.
Okay, and then I had another question for you. What initiatives are you aware of that are taking place for climate change?
There are cities that are actually taking care of some of the issues. You know, there are cities that are really looking for these problems that they already have about flooding and etc. So I hope we all follow the examples. One of the cities that I presented in this index was Minneapolis in Minnesota. They are really preparing for all this because they have an increase in precipitation, 40% increase in precipitation, and they are really trying to prepare for these kind of problems. Yeah.
Okay.
Yes. I see that there is another 3 questions. Can you see them, please, Meredith?
Yes, and taking consideration in destroying our natural ecosystems and pollution, is it our own greed that's ruining our planet?
Well, not really, because I say, you know, imagine the impact of the natural effect. So actually the nature is doing its part, what is going on, you know, about the eccentricity and etc. of our world, what is naturally happening. However, we do in this moment having these urban islands, and yes, we do. We unfortunately are contributing immensely, very big time in that, in regards to, yes, with pollution and taking off all our ecosystems. And there is going to be a moment that everything is recovering, you know, recovering, but there is going to be a moment that probably the damage is going to be so high that we cannot recover. Yes. Is there any other question?
Does anyone have any other questions or comments for Dr. Nava-Fischer? Please, this is the time to put them in the Q&A.
I see Hector Garcia telling, is it people's ignorance a major factor that we haven't taken action?
Yes,
Probably it is, you know, because remember that unfortunately we're still thinking in global warming or climate change like I believe or I don't believe. Remember, we cannot believe. And we as college people, we need to be informed. That's the main thing that probably I would like you to take from here. Get informed, get aware of what is going on with good information, okay? And then I guess that's very much the questions that we have. And I really thank you so much for these questions because as I say, maybe I forgot to talk a little bit about something, and this helped me to actually finalize this talk.
All righty, I think we have everything.
Well, I thank you again for your participation, for being here in this talk. Thank you, Meredith, for your help. And well, we keep in touch. I am in St. Philip's College, and you can send me an email to see. I'm gonna put it in chats, though I don't know if they can see chats.
Yes.
They do? Okay, I'm gonna put my email right there, though I believe probably several of you are in my my classes, so I can actually put my email in right here. Let me just write it. And so I have my email now in the first page of this presentation, which I am going to share right now with you. So in case you want to write it, I have it right here. Okay. So thank you again. And I guess we keep in touch. We keep together in the same effort.
All right, thank you. And you got several thank yous for the information. They really appreciate it.
Keep safe, guys. Bye.
All right, thank you. Thank you for attending.
Thanks.